Hello, everyone. Good day. I want to welcome everyone to our webinar. Thank you for joining us today for our exhilarating blank cost estimation by utilizing blank size engineering BSE in Dynaform 6.0. We have attendees joining us today from Asia, Europe, North America, and we appreciate you taking the time to join our webinar. My name is Kisa Allen. I'm the marketing manager at ETA. For over 37 years, ETA has been the leading provider in engineering software and solutions to clients and customers around the world. Today, we are proud to bring you a webinar on our very own software product, Dynaform version 6.0. Your webinar host today will be Jensen Chen, VP Global Sales and Marketing Dynaform, and Ming Zhang, Senior Project Engineer in Dynaform Support. Just a few items before we get started. If you have any questions during the presentation, please type them in the Q&A box in your control panel, and our Dynaform team member, Molson Mirza, will reply to them as quickly as possible. We will also have time for questions at the end of the webinar. Now, without further ado, I will turn it over to Jensen Chen. Jensen has over 20 years of extensive experience in the CAE field using LS Dyna and Dynaform, along with an extensive knowledge of modern formability, drawdyne development, and die system analysis. Take it away, Jensen.
Hi, good morning, good afternoon, and good evening to everyone across the globe. Thank you, Kisa, for your eloquent introductions. And I also would like to thank all the audience taking your time to join our webinar sessions. My name is Jensen Chen. I am representing ETA. Today, we will be presenting accelerating blank cost estimations by utilizing blank size engineering in Dynaform version 6.0. There's two parts in this webinar. Part one will cover basic BSE, and part two will cover the advanced BSE. First, let's look at the outline for today's webinar. I will go over the corporate overview, following by the Dynaform background and associated Dynaform modules. Then we will discuss about accelerating blank cost estimations. After that, my colleague Ming will be conducting a live demo, and we will have a poll following by a Q&A. With me today, also Mohsin. Anytime during our live demo, you guys can use a Q&A chat box, and he will be answering questions. All right. Here's a corporate profile of Engineering Technology Associates. ETA was incorporated about 37 years ago. We are advanced engineering services supplier. We cater services to Big Three back home in Detroit. In the past 37 years, we developed over 40 vehicle programs, and we currently have 300 employees worldwide. We are also developer of ACP of Design, VPG, Dynaform, and Process. Dynaform has its humble beginnings since 1983, when we started as a small metal forming code. Over the past 3 decades, we slowly evolved the development of Dynaform, and last year we released version 6.0, and we are going to be releasing 6.1 soon. Our market spectrums cover any sheet metal stamping industry, from aerospace, automobile, motorcycles, electrical and electronics industry. Anyone that's doing sheet metal stamping will be our Dynaform candidate. Currently, Dynaform has 6 distinctive modules. We have blank size engineering, formability simulations, die evaluations, die system analysis, blank and trimline developments, as well as tube bending and hydroforming. Now, let's look at part 1 of today's webinar, BasicBSE. We all know that the raw material cost is very crucial for every industry. However, the efficiency is mostly below par due to many barriers. Blank material cost is the key factor in profitability of sheet metal stamping manufacturing. In recent couple of decades, the growth of advanced high-strength steel applications in automobile industry has driven the need for achieving efficiency of blank material utilizations to 70 or 80%. Now, what are your blank cost estimation issues? Are you having pain because the process of getting the blank flattened out is taking a long time? Or you are having a headache because you have too many parts that you need to get the flat blank in a very short period of time? Then again, you might be having frustrations because your profit is diminishing. With that, I'd like to introduce blank size engineering, which have the functions listed here. First, BSE can unfold a blank. Then you can use the flat blank to conduct blank nesting and estimate the blank material costs. At the same time, you can also conduct a quick formability analysis. You can also run trimline estimations using BSE. Here's the process of BSE. We start from a 3D part geometry and extract the meter surface. From there, we will unfold the 3D geometry to obtain the flat blank. The formability analysis is also possible at the end of the unfolding process. Then we will be using the flat blank to conduct blank nesting. At the end of the BSE process, you can also use our trimline estimations to unfold the trimlines onto a die surface. Now let's look at the BSE capabilities. Okay, if you look at the picture on the left side, this is our previous versions, 5.9, and then we have the 6.0 versions. You will notice that the new version is much simpler and intuitive. BSE also supports various native CAD interfaces from NX to Pro Engineer and CATIA SolidWorks. We also support neutral CAD interfaces such as IGS, STL, and STEP. In simple BSE, we will be using a process wizard to quickly unfold a 3D part geometry. The process wizard consists of 11 steps. Most of the time, you will take about 1-2 minutes to go through these processes to conduct a blank size unfolding process. Now, in this basic unfolding, we also provide tipping options. Okay, we can use either automatic options or user-defined options and select the axis of tipping. BSE supports different material libraries from China, Europe, Japan, US, and also user-defined material library. At the end of the unfolding process, we can check the formability results. Then you can conduct simple nestings. There are different types of nesting options. You can select one of these options to estimate the blank cost. At the end, you can also output the formability report on the left side and also the blank nesting report on the right side. These reports are available in PDF and also HTML format. My colleague Ming will be doing a quick demo on the part 1 of basic features in BSE. Now I will talk about part 2, which is advanced feature of BSE. In AdvancedBSE, we can conduct unfolding of tailor water blank, flange, and also 3D parts with a patch blank. There are symmetry and double attach options that you can choose to set up the part geometry. The tipping option is much more extensive. There are different tipping options available. You can also manually tip your part geometry. There is a boundary conditions options that allow us to fill the hole or to conduct joining process of double attached parts. We also have hole filling options in our geometry managers. You can use these options to fill the hole before conducting the blank size engineering process. A constraint features is also provided to set different type of constraints, and this will help us to better unfold the part geometry. Ming will demonstrate these options later on. We will also demonstrate multi-blank nestings. They will be using 3 outlines and conduct the blank nesting calculations. At the end, we will also demonstrate how to estimate the trimline using the trimline options in BSE. I hope with all these features in BSE, we can resolve all your blank cost estimation issues. There will be no more pain, no more headache, and no more frustrations. With that, I would like to pass the torch to my colleague, Ming, to conduct the demo. Ming, over to you.
Yes, thank you very much, CC. Thank you very much. First, I want to welcome everyone for attending our webinar today. My name is Ming Zhang. I'm the senior engineer here in ETA, and also I'm the Dynaform technical support in the US. In today's demo, I'll be showing you several examples. It will include the part 1. First, we will have the simple unfold with process wizard. And also then for the part 2, we will do a double attached blank unfold, tailor weld blank unfold, multiple blank nesting, patch blank unfold, and unfold with constraints. At the end, we will do the trimline unfold. Actually, we do have a lot of content today. So if you have any question during the demo, 2 ways you can submit or ask questions. First, you can type it in the QA part. So you can move your cursor to the bottom, then you will see a QA button. Then you can type your question there. And then at the end of the demo, you can raise your hand. Then we can put your on unmute, and then you can just ask your questions. Okay. So also, Jensen, if you see any question you think it's better to show it in the software, just let me know. Okay. First, we will start with our first example, which is a simple BSE unfolding. For those who are not familiar with our Dynaform software GUI, this is the new, totally new GUI, streamlined GUI. It's totally different from the 594. As you can see on the top, we have all these main menu buttons. And from the left, you will see a tree structure, which will help a lot when you set up the setup simulation. On your right-hand side, you will have the main view window. So for the first example, I will start with a new project and create a new project here and just giving a name, because simple BSE. And I will leave that directory default and start with the BSE. And for this example, we will run the outline formulity and also do the nesting for this simple part by using the process wizard. So I just confirmed the project. So the new project has been created. As you can see now, we have an arrow here. So you don't need to go to the tree and click on different place and set up all these parameters. What you need to do is just go to go click on this process wizard. Go click on this yellow arrow, and then it will guide you through all the process. So I will start to click on this. It will ask you, do you want to run a simple or the advanced unfolding? We will run this simple one. And then the next step is to import or define the geometry. We don't have our geometry imported into the software in the database, so we need to import it. So just click on import, and then we'll pick up our step file. Now, as you can see, the part has been imported. We can move on to the next step. It will ask you, do you want to run tipping or not? For this part, if I rotate it, I will say, okay, it sits on this flat area, it sits on the XY plane perfectly, so I don't need any tipping. I'll just click on none to move on to the next step. So the next step will be defining the material. So once I click on that arrow, it will allow me to pick up some material from our material library. So I'll just go ahead and pick up this DQ, and then just click OK to confirm. And then the next step, we are going to define the thickness. So once I click on here, this part, I use a 1.2 millimeter thickness. And that's everything about this unfolding setup. So now if I click on this next step, unfold, as you can see on the bottom, the progress bar is showing it is unfolding. Now it's finished in just a few seconds. Now on my screen, if I hide my original sheet, you will see the unfold result here. Okay, so if I keep going with our process wizard, it will guide you also through the nesting process. So for the next step, we will run either by coil or plate or progressive nesting. For this case, I will just pick up a coil one. And then the next step, we will select the nesting type. From the view of this part, I prefer to use a 2-pair. So I just pick up 2-pair and then set up the bridge span and the width. I will just leave them default and just keep going and run the nesting. And now just within a second, you will see the result. On the in the result list, you will see we do have a lot of optimized result. On the top, we have the best one. It uses about 69% of the material. So so far we finished all the wizard process. Now we have the both result for unfolding and also the nesting. So for the unfolding, we use a M-step solver, which is a one-step solver. It uses the linear material property during the calculation, means that we can review the result. So in the 6.0, we don't have the pre and post process separated. In 6.0, we unified both of them. So we don't, user don't need to switch to the post anymore. user can directly go to this result button. If I switch back to my unfold result and just click on the result, and then you will see, okay, if I want to check the FLD, I can directly plot it. If I want to check the thinning, I can directly plot them. Okay, let me switch back to my pre, and that means we do have the result for unfolding and nesting. Also, we are able to quickly generate the formability report and the nesting report based on the result we have here. So for the unfolding result, here's the button called the formability report. Once I click on it, it will ask you what the item you want to check. So if I want to check all of them and then click apply, it will just generate this quickly generate this BSE unfolding report. It includes like a thickness and thinning, and thickness strain, major print pro strain, minor print pro strain, and also FLD, this information. Okay. Also, let's check the nesting result. If I'm not happy with this current result, I want to tune it a little bit, like rotate the blank. Here, I can manually tune it just by clicking this menu button. Then I can rotate this, blank 1, or even change it to blank 2, rotate them, or just directly go here and grab this node and just drag it and rotate it. Yeah, that will allow the user to manually tune this result. So if I want to go back to my best result came from the software, I can just click on this reset or maximum button. It will find the best result for you. Okay, the last thing I will talk about here is the generated report for the nesting. So just make one click on the report button, and then you have a lot of parameter. You need to enter them, like the cost of your material, even the blank outline color, name, or file type. In here, I prefer to use the HTML type, and just if I hit apply, now you can see very quickly it just generates the BSE report for you. Okay, I think that's everything about this part 1. Now we will move to our part 2, which is the advanced BSE. So before I start, I will just turn off my process wizard because I prefer to use it, during the simple unfolding. But for the more complex unfolding, I will just turn it off. Okay, so we can do that in the option center in the project. Okay, so for our first example in the part 2, which is the double attached symmetry part unfolding, we will use the same part here. So I'll just create a new project, and then I will just type double attached. Okay, we will run this in the same folder. So I just click OK to confirm. So for the same part, we will run the outline formability and also the nesting. Okay, so now the new project has been created. In here, instead of using simple, we will just use advanced. So once I click on advanced, you will see, okay, in the setup tree structure, we do have a lot of options. We do have more options than the simple. We have tipping, boundary, and unfold. We will talk about and review these options later. So first, for the blank type, we do support the Taylor Weld blank here, and also we do support with the flange, and also with the patch blank. We will also do the Taylor Weld blank and the patch blank later. So in the first case, we will, this is the first example, we will use the same part. We will just first import the part into our database. I will just click on this sheet, and then import our part. It is the same part, we just run it, okay? So now I will just exit this one and pick up my layer. So select this part, define it as our blank, then click on include and exit this window. Now our geometry has been defined. Now I need to go to define my material. I prefer to use DQ. So after I confirm, then you will see at the bottom, I do have this symmetry or double attached function. So for this part, I want to run, both left and right hand side. So I'll switch to the double attached half input because I only have the half of the part. So now we need to go to define the symmetric plane, which is showing red. After we define it, it will turn to black. So I'll just click on define. This is not the plane I want. I will switch to a VW plane and also maybe increase this offset of the plane a little bit. So increase the gap between the parts. So just confirm that. And then let's move to the next one, which is tipping. So for this part, we really don't need to do any tipping. But if you need,
we have a questions.
Yes.
Sorry to interrupt. We have a questions from the audience regarding tippings. Would you please explain, what is tippings and what options of tippings available here in tipping methods?
Yes, this tipping allowed the user to, rotate the part in the space to make sure the unfolding direction is the best. Because if your part, sitting on a different angle, like vertically, if you want to, unfold this in a wrong plane, like now, if I want to unfold it into Z-X plane, the result will not be very good. But if we rotate it, make sure change the position and let it sit on the XY plane. Let the most of the area sit on the flat plane. That will bring you the best result. So we do support auto tipping here. So we do have 4 functions in the auto tipping. We can do the average normal. They can calculate based on the all the elements on the part. They will use the average of the normal, and software the second one will be using the minimum draw depth, and then also user can define just by element normal. And the last one, the user can define by the max width of the part, and using the normal direction of that to as the unfolding direction. Also, user are able to manually tune that. If I want, I can rotate it in X, Y, or Z axle. If I click on it, you will see it is rotating. Okay. For this part, I will not do any tipping. So I'll just reset it to default and move on to the next one. The next one is a boundary. When we look at this boundary, the software has automatically generate the surface here, the lines. I can even change the curvature of these lines. Okay, so after I finish, I will move on to the next one, which is the unfold. Okay, in the unfold, we have 2 options, either by drawing or by forming. The drawing means that you have more options to define your define your forming. Means that if you have your holder force or pad force, it will provide you a more accurate result. So we don't have anything here. I will just click on unfold. It will unfold the part for you. It will just take a few seconds, and we'll see the result. Okay, now the unfold process is finished. We do have the result. We can hide our blank here to review the result. Also, we can move on to next step to do the nesting. Okay, this part will be as same as the last simple BSE. I'll just quickly generate the coil, and I want to use the 2-pair. There's a 2-pair nesting method, and quickly generate that and apply. It will generate the nesting result very, very quick. Okay, now we have the nesting result. That's everything about our first example. Our next example will be our Taylor Weld blank. I will create a new project. It's called the Taylor Weld blank. Also, I will create a new project and run the outline formability and also nesting. Okay. Similarly, I will pick up advanced in the BSE and then I will import our geometry here. Just go to our geometry manager in the Dynaform, and then click on import, and then just pick up the file, step file we need. So this is a B pillar example. Now, as you can see, the B pillar contains three different layers, three different parts. So we will set up them. So in the blank type, this time we will pick up a Taylor Weld blank, and I will enter the number here. Now we are able to define three different blanks. So we will define them one by one. To define them is very, very simple. You just go to your geometry manager and pick up the layer there and include it. That's it. So these are three parts. They have different material. They can have different material or different thickness. So I will assign the first part. I will assign DP500 for the first one. And thickness, I will use a 1.2. I'll just leave it default 1. Okay, so for the sheet number 2, I will just pick up the second one and include it. And for the material, I'll be using 600. And for the second one, I'm using 1.2. Okay, then for the last one, I'm using the surface here, and then define another material, which could be, I'll just randomly pick up maybe 490. And then after I set up everything, now you can see we have three different part of the blank has been defined. They have different material, different thickness. It's very, very simple. So for tipping boundary, I will just leave them default. Once I want to unfold it, I will just click on unfold. This will take 1-2 minutes for saving time. I already have the result here open. Let me switch to this result. Okay, now on my screen, as you can see, we have the sheet 1 and 2 and 3. Three part, they all get unfolded. So for the nesting, if I click on the nesting, the software will generate the nesting for each blank. So for the blank number 1, I have run them all by 2-pair method. So this is for sheet number 1. And then here we do have the result for sheet number 2. And also we do have it for the sheet number 3. Okay, so that's everything about the Taylor Weld blank. Is there any question Jensen, you want me to show it in the software? If not, I will just move on to the next one.
We have an audience asking about the different hole filling options. Would you be able to go to the hole filling in
no
options
problem.
and then demonstrate that we have 2 different options? Yeah.
Yes.
Just quickly show that.
Yeah, we can do it during our BSE defining process in the boundary here. If you see here, we do have this inner fill option. We can just by one click, now you can see all the holes on my blank, they are recognized. And if I hit apply, they will all be filled just by one click. Another way to do it, it's not only for BSE, even for the FS module, the forming simulation module, we can do this operation to all the geometry in the geometry manager. Means once you import the geometry into our geometry manager, when I click on my layer or part, if I want to fill all the holes, we do support all these basic operation, geometry editing operations. Like let me find the right one. Here's the button, remove holes. Once I click, user can either fill all the holes on the surface. Another option is that we can fill the holes by diameters, and then even manually. If I choose manually, I can just pick up the hole I want to fill, then it will just fill that holes for you. Okay. Do you have any other questions, Jensen? You see?
That's all. You may proceed to the next example. Thank you, Ming.
No problem. The next example will be multiple blank nesting. So I'll first create a new project. I just multi-blank. I'll just type the project name and create a new project. So in some case, we do have the nesting result, but you see there's a it is possible to fill some small part in between the blank. Then they may save more cost of the material. So we do support this multiple blank nesting. So in this case, I will remove the outline and from the day only do the nesting. I'll just run the nesting and confirm to generate this a new project. Then if I want to run the nesting, I can run the coil. Then I need to import our geometry into our database. And here I do have 3 different outlines. So I'm going to import them, all of them into my database. And then in the nesting, I run the coil and I need to go to define the material. I just pick up one material from the library similarly, and then pick up the nesting type as a multiple nesting, the last one in the type. Now you can see for the blank outline, we need to define 2 of them. The third one will be optional. So I'm going to define them one by one. So for the first outline, I'll just pick up our line number 1 to confirm. And then for the outline number 2, I just click on it. And similarly to the outline number 3. Okay, so after I select all of them, and then I'll just click on create and hit apply, it will run the nesting for 3 different parts. I also have the result here. This is already finished result. So this part will be the same as the simple BSE. You can tune them, you can change the angle. So the best one in our result list, which is using 67%, about 67.8% of the material. Any question, Jensen?
All good. Please proceed.
Okay, so the next example will be our patch blank unfold. We also do select a patch blank. I'll create a new project. It's called a patch. Okay, in this new example, I will just leave them default, run the outline and formability. And also it's advanced. So next step, I will import our geometry. Okay, here's the part file. This is the NX format CAD file. So we do support directly read the PRT file or CATIA file, a ProE, SolidWorks. So you don't need any CAD translator compared to the old version. It's a lot more convenient. Okay, now I have imported geometry into our database. Now I have 2 layers. The first one is the B pillar itself. The second one is the patch blank. Okay, we'll be using them to define our patch blank. So make sure for the blank type, patch blank is checked. Once it's toggled, you will see the sheet and the patch. They will show in the geometry definition. So for the sheet, we just define them, include them, and then exit, and then go to define the material. Just pick up a DP500, and for the patch, I just pick up the patch. Okay. Also, I will assign a new material for it. It will be a different material. Okay. So let's finish. The setup is finished. So it's very, very simple. You don't see any mesh work. You don't need to fix the mesh. Once your surface come perfectly, the user won't do any mesh fix. Okay, then I can directly go to unfold and then click on unfold. I also have the result here already. Let me reload this result. Okay, now I will just hide the sheet, also the patch. Now, as you can see, the results show is showing us two different blank outline, the inner both for inner patch and the B pillar. And then we can keep moving, either export this line, use them in the CAD software, or I can just directly run the nesting based on these new profile lines. Okay. So next one will be, any question, Jensen?
We're good.
Okay, so next one, we will do a constraint unfolding. So I will create a new project and just call it constraint. So in this example, we will see how we constrain and run a constraint blank unfolding. So we will just create a new project as same as before. So for the advanced, we need to bring our geometry. So I just click on sheet and import our constraint part file. So this is a one small bracket. So the difference between this and the previous part is that this is a solid part. It does have the thickness. It's not only the surface. So actually in the 610, we can, in the geometry manager, we can very quickly generate the middle surface just by one click. First, I click on the layer, and then by using this middle surface function, I can just create this middle surface just by one click. Now, as you can see, we generate this middle surface just in 1 second. And then we'll be using this one for running our constraint blank unfolding. So for the material, now we have defined the sheet. Next step, we need to go define the material. So I'll just pick up something from material library. So for the tipping boundary area, I will just leave them default. For the unfolding, first I will run it without constraint, then you will see the result at how it will look like. So first I will run it, because it's a very small part. It runs, the run finish just in 2 seconds. And now you can see this flat area, because it's sitting on the XY plane. So that pin, I might use that pin as my guide pin. But after the unfolding, this hole does not align with our original part very well. So what we can do here is we can set up the constraint along this hole. So what I can do is in the constraint, I can click on define, and then using the top view, let me switch to top view, and then by using this method and just pick up this node. And then we are going to add constraint in X and Y. So it means this node can only move in Z direction. Okay, so after we finish that, I'll just close this one. And now you can see the unfold is showing red, means you update something, you have to update it. So once I click on unfold, unfold result will be updated. If I take the top view, now you can see the whole, they aligned with our original part very well. Okay. Do you see any question, Jensen?
Yeah. Just to let the audience know, if you have any questions, please use the Q&A box at the bottom or center bottom of your screen. All right, and then you can type in your questions. If the question is related to what we are demonstrating, our pause Ming, and then so that he can demonstrate it.
All right, thank you, Zizi. The last example in today's webinar will be our trimline unfold. So I will just create a new project. I'm just giving the name. And then So now for the new project, we will not run outline, deformability, or nesting directly. We will run this trimline unfold. So I just pick up that trimline and confirm that. To define a trimline unfold is very simple in 6.0. As you can see, only two parts you need to define, the blank and the curved binder. So in the geometry manager, I will go here and import our part. Let me pick up this part. This part it's in the nesting format, means they are already meshed. If I turn on the element edge, you will see they are already meshed. They are not a surface. So if you have surface, you can import them for saving time. Or we already meshed them. So then I can directly go to my blank and then pick up my product, which is showing shows in green in our geometry manager. Just confirm that and then exit. For the curved binder, I'll just go ahead to pick up this die face. Okay, include it. Now exit. Now, as you can see, we do have our blank and curved binder both defined. Then we are going to define the material. I just pick up DQ from the material library. That's everything I need to do. Then if I click apply, they will just start running the unfolding process. Now let me switch to my result. Here is the result for the trimline unfold. Now, as you can see, we do have the new trimline sitting on the die face. Yeah, actually, according to the feedback and from OE and our customer and die shop, compared to our competitor, our trimline unfolding to have a very accurate result. We are still leading in this industry in the trimline unfolding. Okay, I think I do covered everything, right, Jensen? I think that will be the end of our demo today. Now
Yes.
I will just start the pooling. We really appreciate your opinion and feedback. That will help us a lot, to improve our software in the future. So it will take just 1 minute.
Yeah, we'll give you guys a couple of minutes. We appreciate if you guys can just answer our poll questions. And after that, we will be proceeding to the Q&A sessions.
Also, if you have questions, you have connected with our audio to this webinar, you can raise your hand. Then I will put you on unmute.
There seems to be a little issue with the submit button. Can someone look at it?
I see. I don't see that. Sorry, Jensen. I think it's working fine.
It's gray out, according to Jimmy. Sorry, Jimmy.
Yeah, thank you very much, Jimmy. You want to vote for 11, I know.
Paul just said it's working fine over there in UK. So Jimmy, please try.
Hey, CC, do you think there's one question I see he asked about the progressive die strip layout.
Yes.
I could show that quickly.
Is the poll over? Yeah, I think we have 2 minutes, so the poll is over. I think.
Yes, let me end it.
Yeah. Yep. So now let's move on to the Q&A. We got a question asking about the progressive strip layout. It is a feature that we plan to implement. Okay, not in the existing versions. Okay, but there's also another question regarding how to do nesting of progressive die. All right, so it's two different questions. All right, the first question is about strip layout. Okay, that we require to implement a new methods of unfolding the blank in a different angle. Okay, the next question is about nesting of progressive die, and this is what Ming will demonstrate now. If you have some parts made of progressive die process, then you can use this option here to nest your parts. You can add the carriers and then adjust the carriers, and then there are different type of carriers, and you can also include the pilot holes in here. So it's quite a niche feature in BSE. Again, if you have any questions, you can raise your hand. Then we will unmute you and you can ask questions so that we can answer your questions. Yeah, we have a questions from Paul about the increased number of parts in coin nest. I think it's referring to the multi-blank nestings. What is the maximum number of blank available now? Supported by BSE.
Yeah, currently we support up to 3 blanks for the multiple blank nesting.
Are there any plans to increase that number?
Yes, we're working on that. Maybe in the future version, or we're able to increase that number.
Okay, good.
Hey Jensen, do you see any other questions from the QA box? I don't see anyone raise hands. I guess we need to answer all these questions from the QA. I think we answered this one. And
yes, we have a question from Jimmy about the strip and carrier developments. I like to answer that. It's under developments. We are going to include more options for the strip and carrier developments. Currently we just have a few options. So. And we are going to add more in future releases.
okay. If there's no more question, I will just give the time to Kisa to wrap up.
I do have one last question for
yes,
you, Ming.
go ahead.
Yeah, because you were doing the part 1 and part 2, so we didn't know how you're gonna switch between the wizards and the advanced feature. Would you tell us how you activate that feature?
Yes, I did it in the option center here. Once I click on this project and then go to my option, then under the BSE, I can just set up, the default for the BSE general. I could launch the process wizard every time when I create a new project or not. So here's the place to set up it. I will just turn it on, then click OK. Then for all the new project, the process wizard will be there. And then you will see it there.
Okay, great. Thank you, Ming.
Yeah, no problem.
That's all from my side. So,
Okay, I think we do not have more questions. Kisa?
Yeah. Okay. Thank you, everyone. We truly appreciate everyone for joining us today. We have a number of webinars planned for the coming weeks, and we hope you can join us. Following this webinar, please check your email. We'll be sending you a few short survey questions. Your answers are beneficial in shaping our future webinars. Again, thanks for joining us today and stay safe. Thank you so much.